Hello friend, welcome to Data Lux. In this video, we are going to discuss a problem from the machine learning MCQ type, and this is from the logistic regression. The question here say in logistic regression, the hypothesis function is defined as the given option is h of x equal to w raised to tx, and b is h of x equal to log 1 plus e raised to minus w or raised to tx, and c is x h of x equal to e raised to w or raised to t x, and last is h of x equal to 1 plus 1 upon 1 plus e raised to minus w raised to 2 into x, right? So these are the given options and we have to find the correct one. So before going to find the correct option, let us see what is the logistic regression and hypothesis function. So as we know, logistic regression is a in machine learning is a supervised machine learning algorithm. So this is the supervised machine learning algorithm and used for classification problem, right? So this is the mainly used for the classification problem. Unlike the linear regression, so as we have also we know there are another type of regression, that is a linear regression. So in linear regression, we predict a continuous value right here. So in case of linear regression, we get the continuous value like this one. And but in this case, in case of logistic regression, we get the probability. It predicts the probability, and that an input belong to a specific class. So as we know, in case of probability, we get the value between the 0 and 1. So this will predict the probability value, and according to that value will classify certain uh, uh, problem, right? Yeah, we classify according to that given probability. So if you say this is used for the binary classification where output can be one of the two possible categories such as the yes or no type, true and false type, or 0 and 1, right? So this will be the category for the binary classification. And to find this value, we use the sigmoid function, right? So we use the sigmoid function to convert inputs into a probability value between the 0 and 1. So for that case, we use this sigmoid function as we here is mentioned. So this is the sigmoid function, use this one. And if you see this value, this will always predict value from the 0 to 1. So it ranges from the always 0 to 1 right here. So this is the function of the sigmoid function. If we see type of logistic regression, so we have here the three type of logistic regression. One is the binomial logistic regression, and second one is the multinomial logistic regression, and last one is the ordinal logistic regression. So in case of binomial, if you see here, this type is used when the dependent variable has the only two possible categories right here. As we have discussed, it is the yes or no, fail or pass, 0 or 1. So this is the most common also form of the logistic regression and used for the binary classification problem. And if you see the multinomial logistic regression, so this is used for the uh, multiple categories. For example, we have to use when the dependent variable has the three or more possible categories that are not ordered right here. And for example, if we classify animals, for example, into many category like cat, dog, sheep, etc. So this will be the multinomial logistic regression, and it extend the binary logistic regression to handle the multiple classes right here. And next one is the ordinal logistic regression. So this type of applies when the dependent variable has the three or more categories with the natural order or ranking. So in case of ordinal, when we categorize into order, right, that is the or we rank something. So for example, as we know, low, medium, high. So this is the rank. So this is the in this case we apply the ordinal logistic regression. So it takes the order of the categories into account when the modeling. So as here the order is important. So when we categorize, so it take the order. Now if you see the hypothesis function for the sigmoidal function or logistic regression. So this is the as we know logistic regression model compute. So this is the this if you see this is the linear combination of, so here is the z equal to w raised to 2 x plus b. So as we know w is the weight and x is the variable plus b is the error value here. So when we apply this function, so this our hypothesis function will get here h of x equal to sigma z, and we convert this into 1 upon 1 plus e raised to minus z. So if it's z, we can replace also z with the this function. So here is the w raised to 2 plus x. So this is the our hypothesis function here. And this compress the output into range of 0 and 1. So as here we have discussed, so the value of this function we always will get the from 0 to 1, between the 0 to 1, right? So this compress if you and input ranges any value right here. So if you provide any value of so this always result in the 0 to 1. So if this minus infinity to plus infinity, and here the 0. So for any value of this range, you will get always the 0 and 1. So this compresses the output into range of 0 and 1. And what is the decision rule here? So for decision rule, first we find the threshold value. So in this case, we pick up a 0.5 as a threshold value. This value also can vary according to our problem. So this is not a fix. This is the defined value. So here in this case, as here this is mentioned 0.5. So this is the threshold value. So if the our value above the 0.5, it will class the 1. This is the one that is the or we can say yes or no category. So if the value is for example spam or not spam, so we can categorize according to this value. So if it is greater than 0.5, we can say yes, or if it's less than 0.5, we can say no. So here the output value is if the threshold value is 0.5 or hypothesis function greater than 0.5, we say 1, assign 1, and if less than 0, that is the this is the 0 here. Less than 0.5, this will be the 0 here. So threshold value can be changed depending upon the problem, as we have discussed. So this value also can change according to a given problem here. And if you see the application of the logistic function, so logistic regression, so there are many application of this function. So we use in the medical diagnosis, so predicting whether the patient has a disease, certain disease based on the clinical feature. Credit risk scoring, so assessing the probability that the borrower will default or on a loan, particular loan or not. So we can, by using this logistic function, we can predict the defaulting case here. Similarly, marketing customer churn prediction. So estimating the likelihood that the customer will leave a service or not. Spam detection. So this is the very common. Classifying spam or not spam. Fraud detection, identifying suspicious or fraudulent transactions, and natural language processing. So this is also very important topic. Here we also use this for the categorizing text into the predefined classes such as sentiment or the topic right here. Now again, let us come on our problem. So in logistic regression, the hypothesis function is defined as, so if you see the first option, so this is the linear regression, not a logistic. So this is the linear case, linear regression. And this is the a logistic loss function. So this is the logistic loss function. And if you see this is the exponential, so this is the exponential function. And if you know exponential function, this like this one, So if you see this, the output from this always greater than 0 to infinity. But in case of logistic, as we know, our value belong to 0 to 1. So this is also not true. And if you see, this is our correct answer. So these are these first, this is also incorrect, this is also incorrect with respect to logistic regression hypothesis function. So our last option is the correct one. So that's it from this video. If you find this video informative, please do like, share and subscribe this channel. Thanks for watching.